Good morning, students. So let's start with chapter number 1, number system. This is part 1, all about the introduction of the chapter class 9 maths by your Sonali ma'am. Let's begin. In this chapter, we will all talk about the rational number, irrational number, terminating and non-terminating rational numbers. So in the world of maths, number can be labeled in two different categories. First is rational, any integer, positive or negative number that can be written in the fraction or the ratio, which is p by q, where q should not be 0. And irrational, any integer, positive or negative, that cannot be written as the fraction. Now you can see the chart here, rational number versus irrational numbers. So rational numbers, you can see that they are natural numbers, integers. Here in this flow chart, you can see that the rational numbers, they are made up of integers, natural numbers and the whole numbers. Whereas irrational numbers are all made up of the roots which don't have the perfect square. This both together form the real numbers. Now rational number on the number line. So you already have studied how to draw the number line. So negative numbers are always on the left side, positive right side, center 0. Now if you want to plot a rational number on the number line, first of all you need to find out its exact root. Once you find the root of that number, you can place that number on the number line. Rational number. Look at the word rational. What word do you see in them? Ratio, null. What does this word mean? Rational number, ratio, null. The term ratio refers to making a comparison of two different numbers, such as 13 girls to 15 boys, which is 13 is to 15, or you can also write 13 upon 15. You may remember that we can write a ratio in three ways: 13 to 15, 13 is to 15, 13 by 15. Because we are able to write ratio in the form of fraction, we can identify this number as the rational number. Rational number. What about the whole numbers? Why are they considered rational? Turn on your neighbors and discuss why 3 is considered as a rational number, because you can also write the 3 as 3 divided by 1. So which is in the form of fraction. Remember that all whole numbers can be written as fraction just by putting a 1 underneath it. Therefore 3 can be written as fraction and is considered rational. Decimal and rational numbers. If a decimal forms another way to write the fraction, does this mean that every decimal is a fraction? Yes. 1 upon 2 is 0.5, that means 5 upon 10. 1 upon 4 is 0.25. 3 upon 4 is 0.75. This is where it gets confused. So decimals and the rational numbers are expressed as the ratio which repeat or terminate. Terminating decimal, think about the word terminate. What does it mean? Now 0.5, 0.75, 0.287, 0.89. Notice these decimals end on their own. These numbers were not rounded. They are terminated. So terminating numbers are called the rational numbers. Terminating decimals, you can see here 5 upon 10 is 0.5, 75 upon 100 is 0.75 or 3 by 4. 287 is 287 divided by 1000, or 89, which is 89 upon 100. So these are terminating decimals, which can be also a rational numbers. Repeating numbers. Now when you divide 1 by 3, you will always get answer 0.3333. That is non-terminating repeating number. So this 3 will never end. They will repeat forever. To represent the repetition in the decimal, we can put a line over the first time the repeating number which is shown, and then drop all the numbers behind it. That is called the bar. So you can also call this number as 0.3 bar. Repeating decimals, they will never end. You can see that I have put 0.3 bar here. Anytime you transmute a repeating decimal, you must put a line above all the number, which is called the bar. Repeating decimals 0.676767 dash dash dash. You can write 0.67 bar. Here next is 0.2453 bar, 0.897 bar, 0.2 bar. Repeating decimals can be written in this form. Now you know the perfect square 1 to 10. So whenever you make a root of this numbers, like example under root 4, under root 36, under root 81, they are the rational numbers because they are the perfect square of some or the other number. Irrational numbers. Have you ever heard someone say you are being irrational? What do you think that means? Irrational numbers. Quickly turn to your neighbor and talk about why this image is irrational, because that point, now you just know that will go on and on, it will not terminate. So the term irrational is defined as something that is illogical or unreasonable. In other words, it does not make any sense. You can see the value of pi here, how you just imagine the value of pi. It doesn't make any sense, so it is irrational, never ends, it goes on. Irrational number. Let's think about the pi. You can see here. Now, irrational number, if pi never repeats and if pi never ends, how can we write pi as a fraction? Now, irrational numbers, because we cannot write pi as a fraction, we call it irrational. Other numbers include the following, which are under root -1, under root 2, under root 3. We can go ahead with so many other choices. Irrational numbers, we may get long answers or even an error message. This indicates that number is irrational. Now, the rational and irrational difference at the glance. So, rational numbers, they are perfect square. Irrationals are not perfect square. Rational numbers are in fraction unless they have 0 as a denominator. Irrational numbers are not in a fraction. Rational numbers are repeating decimals. Irrational numbers are non-repeating decimals. Rational numbers are terminating. After certain repetition, they might get terminate. Irrational number, they are non-terminating decimals. So I hope you are clear with rational number and irrational numbers differentiation. So this is all about the chapter. In this we will study more about rational numbers and irrational numbers and how you can represent them on the number line as well as the simplification of both. So kindly go through the next videos, which are the textual exercise of the same. Thank you.